Hello, I'm Joyce.
Hello, I'm Matthew.
For our project Foodaverse, we are interested in exploring the connection between food and flavors, as well as data visualization inside of virtual reality. The problem that we're trying to solve here is visualizing dense data inside of virtual reality. In the talk, Designing Virtual Reality Data Visualizations offered by Anna Becker in 2016, she proposed that data visualization in virtual reality should have low information density, as it is, and I quote, hard to read inside of VR. Another problem VR data viz run into is perception difficulties, as humans are not very good at reading 3D graphs. In our project, we hope to bring the principle of zoom, filter, and details on demand into VR data viz in hope to offer a solution to the problems proposed. But first, let's take a look at our dataset.
We use the FoodB dataset, which covers more than 790 food entries and over 70,000 flavor components. We were able to visualize 636 food ingredients in the end and categorize them into 9 food groups, and then parsed all the flavor compounds into 9 categories. Each category corresponds to a color.
To visualize the relationship between food and flavor profiles, we created a cylindrical parallel coordinate system. Although in 3D, the user is still viewing a 2D data viz. This helps with readability by avoiding the strain of interpreting 3D data points. Additionally, the user can scale the axes vertically and horizontally. These were designed to allow the user to zoom, focus, and create a more readable data visualization for themselves.
To scale horizontally or vertically, users have to squeeze their hands into fists and move them apart from each other either on a vertical or horizontal level. After scaling the axis, the user can travel up or down to focus on any section they want. The user can use a filter tool to isolate specific food groups. They can access the filter tool by tapping an arm interface on their left hand. At that point, a menu will pop up, asking them which food groups they would like to view. They can view one group and see the distribution, or compare several groups at once. A user can tap the button to add a group to the filter.
The line visualization intends to show the relationship and trend within the data, but if the user so desires, our visualization can also display the axis average in the form of a sphere, which removes visual clutter and makes reading the data faster. Finally, the user can go up to any given point on the chart and select it to see more details on demand. Upon selection, a widget pops up with the image of the food, description, and other information taken from the FoodB dataset.
One of the insights we gained while working on this project is to use the right medium to represent the right data. VR's strength for visualization is its ability to represent spatial data well. Theoretically, it's much better to visualize data that is inherently spatial, such as the track of a player during a tennis match, unlike our numerical data.
That being said, our visualization technique differs from existing VR data viz, since contemporary VR data visualizations focus on smaller, tabletop visualizations, whereas we invert this by representing the data as the environment that the user can explore and manipulate. Each technique has their own strength, but we believe by giving the user the right tools, our method may overcome the existing problems in VR data viz.